You're live.
Good morning. My name is Tamu Gibson, and I'm serving as a designated federal officer to the U.S. EPA Science Advisory Committee on Chemicals, SACC. For this meeting and in my role, I will be opening the last day, the fourth day of the public meeting on EPA's review of the 2024 draft risk evaluation for formaldehyde. I'd like to repeat that SACC meetings are subject to all FACA requirements. These include open meetings, timely public notice of meetings, and document availability to the public. All documents are available to the public in the docket at regulations.gov. As a reminder, this meeting is being webcasted, transcribed, and recorded. A live stream of today's meeting is available on YouTube. And you can refer to the link on the meeting website, the SACC meeting website, which is also has links to each day of the meeting since May 20th, which was day one. I would like to thank my colleagues at EPA, the peer review and ethics branch, as well as my colleagues in OPPT, for all of their hard work in preparing and presenting this meeting. I would like to thank the chair, Dr. George Cobb, for chairing yesterday's session, and to the committee members and ad hoc reviewers for responding to the charge questions. I also would like to thank the public for also participating in yesterday's meeting. At this time, we will continue with the deliberations of the charge, and I now hand it over to our chair, Dr. George Cobb.
Thank you, Ms. Gibson. This is George Cobb, and I'd like to echo the welcome to all of the public who are watching, the committee, and the EPA staff. We've had a long 3 days. We're in the home stretch, and as is tradition, I'd like to begin by seeing if there are comments, clarifying comments from the previous day's discussions. And I did get one indication of a desire to speak from Dr. Heiger Bernays. So I'm going to simply, instead of asking for questions, I'll turn it over to her for her comment, and then let others decide if they have comments as well. They are certainly welcome to do that based on what we've talked about in our deliberations so far. Dr. Heiger Bernays.
Excuse me, 1 second, Dr. Cobb, we need to conduct the roll call.
Call the roll. I forget to call the roll. Let me find my roll.
I'm ready to go.
Give me a second. The roll is buried. The roll is buried. Where's the roll? There it is. Okay. Apologies. Dr. Apte.
I'm here. I'm used to going first for pretty much entire my life being A, and so I was waiting for it. So
Yeah, Dr. Baker.
Here.
Dr. Jason. No, I saw Chris somewhere. Dr.
Apologies,
Ike.
I'm here. Thank you.
Dr. Ike.
I'm here. Thank you.
Great. Dr. Fox.
Here.
Thank you. Dr. Graham.
I am here.
Dr. Heiger Bernays.
Here.
I see you. Dr. Merced Nieves.
Here.
Dr. Ottinger.
Here.
Dr. Presbilla.
Here.
Dr. Rife.
Here.
Dr. Rubin.
Here.
Dr. Voorhees.
Here.
Mr. Wright. There.
I'm here.
Mike. Dr. Barakal.
Here.
Dr. Bricey.
Here.
Dr. Henneman,
Here.
Dr. Caden,
Here.
Dr. Kelly,
Here.
Dr. Kemp,
Here.
Dr. Landis,
Here.
Dr. McClellan,
Here.
Dr. Strickland,
Here.
Dr. Sweeney,
Here.
Dr. Wolf,
Present.
and Dr. Jong.
Here.
All right, thank you. I think we got everybody. And now we'll turn this out. Let Dr. Hager Bernays speak to the comment that she had from yesterday.
Great, thank you. Wendy Heiger Bernays. I should have made comments during yesterday's meeting, but it was the end of a very long day. I'm going to thank the respondents who prepared comments to questions 5.6 and 5.7. And I'd like to revisit a statement that I thought I heard, and that was, does EPA think that homes are toxic? And a related statement with regard to rates of asthma and upper respiratory, related to rates of asthma. I suggest that many homes, like schools, as we heard yesterday, have inadequate ventilation such that emissions of formaldehyde from various sources that are being evaluated by EPA and those that are not, such as releases from gas stoves, can be present in concentrations that are problematic for people living in homes without adequate ventilation. And I think this will be addressed again later on. But with regard to rates of disease, specifically asthma, tracking and compiling these rates, both new cases and exacerbations, are underreported, particularly for people who live in places in the US that lack healthcare infrastructure and access to clinics. So comparing applying the POD to rates that are published is challenging at best and perhaps not the best science. We don't have adequate epidemiological estimates for rates associated with in-home exposures to formaldehyde for multiple reasons, many of which we've already discussed. And I suggest that stating that rates of formaldehyde-associated disease don't square with concentrations or predictions based on application of the chronic POD is problematic, which gets us to the MOA. Using the MOA is important, as stated, using the MOA as the mode of action, as the basis for harmonizing the cancer and non-cancer values, as I think I heard yesterday, but I did not read the final statement, results, I think, in the use of a threshold value below which there's an assumption of no effect, as mentioned in prior comments, is not consistent with the best available science. Thank you.
Okay, and Dr. Hager Bernays, can you make sure that information gets to the lead for this charge question?
I can, thank you.
Right. Other comments from our discussions yesterday? Dr. Fox.
Great, thanks. Yeah, so this is in the spirit of, sorry, Mary Fox speaking. This is in the spirit of no surprises. So I just wanted to note for the record for questions 3.3 and 4.4. So it will add context about a unified approach to dose response from the National Academy's Science and Decisions report. Just wanted to get that on the record. Thank you.
You're on mute, George.
Thank you. This is George Cobb. Thank you. Those kinds of fleshing out are always important. So thank you for that comment. Okay. Let's move forward to the agency, the EPA. Do you have any questions that have cropped up since we last spoke about yesterday, or shall we move into charge question 6?
Hi, good
No.
morning. This is Michelle with EPA. We don't have any additional questions or anything, so we can move on to the charge questions.
Great. And do I understand that that's going to be Mr. Grosna?
Yeah.
Grosla, excuse
Right.
me.
Yep, sorry. And I should say my last name. This is Rochelle Bahati with EPA.
Thanks.
Dr. Cobb, this is Mike Wright. I did have a comment about yesterday's discussion.
Mr. Wright, I'm sorry, I did not see your hand raised,
Okay.
but yes, please.
That's right. I've sent a statement to those to the other discussants for 5-7, and I won't read that into the record because I assume it's already there, but I'll make a very brief comment about it. I think that and first let me apologize for not raising these things yesterday. It was, as Dr. Heiger-Bernays said, it was late in the day. I think a lot of us were consumed by other tasks and things went by kind of fast. I said I had no comments at that time, and I do have some this morning. I think that I want to remind everybody of Carl Sagan's statement that extraordinary claims require extraordinary evidence. The claim that there is a threshold for formaldehyde carcinogenesis is extraordinary in the sense that it is beyond the ordinary. The ordinary is that so far as I know, no federal agency has ever used a threshold model for carcinogenic risk estimation. I don't believe IARC has either. IARC did consider formaldehyde. It used a linear no threshold model. It also based that model partly on myeloid leukemia. I think that those who claim there is a threshold have made a good case, but I don't think it's the only case that can be made. The recommendation in particular from 5-7 suggests that EPA go back and consider the best available science, which is a very good recommendation, but then it seems to go against that recommendation by saying what the best science is, which is that EPA should use a threshold model for carcinogenesis. I think, in fact, EPA should look at both and should really evaluate both and should do it based on the evidence, and whichever model it chooses, it should be prepared to defend that. I think there were a couple other problems in statement 5.7, and these are basically wording. One is that the way it described the National Academy's review was, I think, more, if I can say this gently, I think was more polemic than it was scientific in putting quotes around the words risk assessment and in using the words so-called. I'd also like to support what Dr. Heiger-Bernays said, that the statement, and I'll say it my way, that the statement that the current analysis indicates that homes are risky. Yeah, homes are risky. Homes are risky from a lot of things. And simply saying that formaldehyde may be a relatively slight risk at low levels it is not an unreasonable statement. So I think that the final report should reflect certainly that there is evidence supporting a threshold effect for formaldehyde, but it's not the only possibility, and EPA should consider both. Thank you.
All right. Thank you for that comment. Dr. Wolf.
I feel obligated to correct two comments, Mr. Wright. One is Using a threshold model for carcinogenesis is not extraordinary. It's very commonplace and used all over the world by regulatory agencies. It's a frequent approach for many pesticides and other chemicals that have a non-mutagenic mode of action. And so it is not extraordinary, but actually routine and well characterized, well described in the 2005 cancer guidelines. The other thing is the IARC monograph program is not a regulatory agency, and they don't do risk assessment and don't use any kind of models to assess risk, linear or nonlinear. They're a hazard identification program. And so that's an important distinction. Thank you.
Thank you. And if you can both make sure that our lead discussant gets that information. I think, Mr. Wright, you were on that charge question, if I'm not mistaken. So you're part of that writing team. And I might point out that it is often the case that we have differing perspectives from the committee members, and that is perfectly fine as long as we get that on the record and then capture it in the written report. All right. So let's go back to EPA now and get charge question 6.1 read into the record.
Hi, this is Brian Groza from EPA, and I'll be reading in charge question 6.1, air monitoring data. The draft ambient air exposure assessment for formaldehyde characterizes the available outdoor air monitoring data as representing aggregate exposure from all sources of formaldehyde in outdoor ambient air, including TSCA conditions of use, as well as other sources of formaldehyde. The EPA's Air Monitoring Technology Information Center, or AMTIC, was determined to be the source of the most current nationally representative outdoor ambient air data. Please comment on the strengths and limitations of AMTIC, its application for this draft formaldehyde risk evaluation, and the conclusions that the data represent aggregate sources of formaldehyde in the United States. Please also comment on the appropriateness of any other outdoor ambient air monitoring data that could be considered in the formaldehyde assessment of outdoor ambient air. Lastly, comment on the extent to which the weight of scientific evidence narrative is supported by current outdoor ambient air monitoring information for formaldehyde.
Thank you. So now we can turn this over to our lead discussant. And for 6.1, that will be Dr. Henneman.
Great, thanks. And just a note, I'll be reading in the first about 2/3 of this, and then my co-committee member, Dr. Barakal, will read in the second part. Okay, here we go. The plan of EPA in using this data is to obtain a representation, albeit at sites sparsely located across the United States, of the ambient formaldehyde concentration that is reflective of all sources of formaldehyde, from industrial releases to biogenic processes and secondary sources. By comparing AMTIC monitoring values with the estimates of ambient formaldehyde concentrations that the agency obtained using the IIOAC model and air tox screen would enable the agency to perform some sort of source apportionment and draw conclusions regarding the contribution of each source to the total ambient formaldehyde concentration. While in theory the plan seems reasonable, particularly considering lack of better data sources of information and more specialized monitoring data, there are questions about the implementation of the plan. And we have some recommendations. Although the AMTIC data has potential to shed some light, maybe more at a qualitative than quantitative level, the current use of these data does not allow to draw well-founded conclusions. And to wrap up the sort of beginning part, some information of the AMTIC ambient monitoring data, for example, how or whether daily average or annual average formaldehyde concentration could be calculated, is not mentioned in the draft report to ambient exposure to formaldehyde, and it would be helpful if that information is reported in the document. Okay, so first section is strengths. AMTIC appears to be a great source of information on ambient formaldehyde concentration. As EPA states, AMTIC has received a high quality rating from EPA's systematic review process. And a strength or a strength that wasn't addressed is that the monitoring values should have lower uncertainty than modeled concentrations or contributions from other sources. Observations also do consider environmental chemistry, transport, and deposition, which includes contributions from both anthropogenic and natural VOC emissions to formaldehyde, although along with considering anthropogenic formaldehyde that is emitted and transformed in the atmosphere to other chemicals. Based on the figures, AMTIC is generally nationally representative, although by the figure, only monitors in the lower 48 states were considered, and looks to mostly be in urban areas, which is more representative for population exposure. But it'd be useful to identify and summarize the nearby formaldehyde sources, for example, in TRI or NEI, and we have some more comments about that down below. Okay, next on to limitations. As the agency elaborates in section 3.2.1 of the draft ambient exposure and in section 2.4.1 of the draft human health risk assessment, AMTIC data is heterogeneous in terms of methodology used to measure the concentration, and consequently the limit of detection. The reliability of the instruments used to measure the concentration and the timing and duration of the measurements, anywhere between 5 minutes to 24 hours. It's also unclear what the form of the measurement provided by the AMTIC data. What is the form of measurement? Are the monitors reporting average concentration over a specific time interval? Are they reporting total or maximum concentration over a specific time interval? And it would be useful to have indication for what the format of the concentration measurement is. One committee member let's see. A committee member's inclination would be that the reported concentrations are averages, but the statement in line 787 of the draft ambient exposure that the formaldehyde concentrations were not otherwise normalized by sample collection, duration, or methodology seems to indicate that maybe the measurements are not provided in the form of averages, and more clarity here is requested. So this was a strength, but it's also a limitation that the ambient data includes everything, both primary emissions and secondary formation from all cases, both included and not included in this risk assessment. I think there's reasonable discussion of that in the document. Related limitation of AMTIC data specifically is not considered as formaldehyde's contribution to secondary pollutant species like ozone and secondary organic aerosol. This may be out of the scope, but these downstream impacts are real and important to acknowledge. Okay, comments on application to this risk evaluation. It'd be helpful for EPA to lay out in a perfect world what modeled or measured output would be sufficient for this risk evaluation. It sort of starts out with a description of the tools that are available or used, but some acknowledgement of what simplifications or uncertainties are acceptable and how these relate to the tools available would be useful. It's unclear how representative the monitoring data is for an annual average. One thing that would help would be to summarize the data based on time of day covered by the measurements. An issue with taking the annual average or average across multiple days does not consider short-term spikes, but these could be identified by assessing the temporal variability in the data, for example, with a smoothing temporal filter and identifying outliers. This could be useful, especially if the data is linked with nearby TRI facilities to identify locations and times when air emissions happened. All right, figure 3.3-7 in the draft ambient exposure showcases a map of the AMTIC monitoring sites, which might seem to indicate that most of the monitors are located in urban areas rather than rural, though it's difficult to tell. And it also looks like most of the AMTIC monitors provide measures of formaldehyde over a 5-minute interval. Given the transience of formaldehyde and its different half-life length in the presence of sunlight, it's important to know when during the day the 5-minute AMTIC intervals are collected. The agency investigated variability in ambient formaldehyde concentrations from AMTIC monitors based on methods of collection and durations of collection. As for what concerns collection, it seems that the 5-minute monitors tend to report lower concentration values than the other duration of collections with an occasionally larger value. Again, given that formaldehyde tends to be unstable and react based on meteorological conditions, understanding what is the spatial distribution of the AMTIC monitors and the timing of day of these measurements is fundamental. A question about figure 3-7 and suggestion to make it clearer. Comparing values across monitors is difficult given the many confounding variables that might have an influence on the value reported by a monitor. The location of the monitor, is it rural or urban, the time of day, and the year the measurement is collected, the method of collection, and the duration of collection, to state just a few. Simply averaging the available monitors reported by an AMTIC monitor over the course of a year without taking into account these confounding factors and creating plots of the distribution that lumps all the values together, as in figure 3-8 of the draft ambient exposure, without considering the spatial location of the monitors, and comparing it to the other models is not quite fair, as the comparison does not take into account all of the confounding factors. Another specific question about figure 3-9, finding it somewhat confusing. Next section, conclusion that the data represent aggregate sources of formaldehyde in the US. Given the spatial misalignment between AMTIC and the IIOAC data, it suggested that a different approach would be to use AMTIC monitoring data, assume that the measurement represents a daily average concentration regardless of the duration of collection, and fit a spatial regression model that regresses the measured AMTIC observed concentration data at a given AMTIC monitor on the various confounding factors above. And there's some description about the specifics of how that model might work that I will skip here, but include in our report. Alternatively, the agency could calculate average AMTIC concentration averaged over all the AMTIC monitor locations that are within a certain distance buffer from a TRI facility, and could compare the IIOAC modeled concentration 100 to 1,000 meters from a given TRI facility to this more localized average AMTIC concentration. Comparing distributions lumped regardless of the spatial locations of the monitors, and thus disregarding the actual spatial distribution of the concentrations, is not meaningful. To understand this, imagine we reshuffle the average annual formaldehyde concentration at the AMTIC monitors, but we do not reshuffle the IIOAC values. The overall distributions for formaldehyde concentrations relative to AMTIC and IIOAC in figure 2.10 of the draft human health risk wouldn't change, but the spatial distribution of the AMTIC average annual formaldehyde concentrations across the United States would have. This has important consequences when one wants to draw conclusions regarding that percentage of the total formaldehyde concentration that on average the population is exposed to is due to releases connected with the TSCA COUs. To draw conclusions on those percentages, one would have to calculate the ratio of the annual average formaldehyde concentration due to TSCA COUs at a location and the annual average formaldehyde concentration due to all sources at the same location. And then there's a recommendation, we've heard this before, about including information based on consultation with the Office of Air and Radiation related to EPA modeling activities related to regulating formaldehyde as a HAP and as a contributor to ozone and PM under the Clean Air Act. And I will stop there and hand over to Dr. Barakal for the next portion.
Yes, hi, this is Dr. Barakal, and I will be discussing the issue about appropriateness of any other outdoor ambient air data. So I first want to start by acknowledging that within our group, we had a discussion about the use of the word data, what can be called data and what data means for different disciplines. And so I think for statisticians, typically the word data means something that is only that is used to make inference and to learn. Everything else that is the result of inference from a model for statisticians is not considered data, but it's an estimate. I think right now, in general, given the explosion of data science, it's more typical to think about data in a broader sense. And so data typically is used as a catch-all terms for numerical evidence. I think regardless of what is the nomenclature that we're going to use, it's very important to acknowledge the sources of uncertainties in any data use, whether it is monitoring data that results from a model or from some other combination of observation and models. Next, I want to comment about the fact that EPA mentions that there is available data on formaldehyde concentration from satellite data that can provide insights on the temporal and geographic trends that can characterize ambient formaldehyde concentrations. And we have some references to provide here, but it doesn't seem that that data was considered. That data might help understanding some of the spatial variability. I wanted to provide some insight on satellite data and remote sensing data, given the discussion about potentially using remote sensing data. So the first comment I want to provide is that remote sensing data that is typically considered by many as observational data, in reality, it's an estimate that results from the application of a model that solves what is called an inverse problem, in that instruments aboard of satellites do not measure air pollution concentration and thus do not measure formaldehyde concentration, but they measure the reflectance of light. Then different models based on physics and other understanding are set up, and the statistical models and algorithms are set in place to then try to retrieve from the light reflectance what is the concentration of a chemical or an air pollutant in the atmosphere. So that is likely how measurements, quote unquote, of ambient exposure formaldehyde concentration are obtained from remote sensing. Thus, it's important that if we use remote sensing information on ambient exposure formaldehyde concentration, we acknowledge the many sources of uncertainty that this data is characterized with. There is the uncertainty connected to the method that is used to perform the estimation. There is the uncertainty in the measurement of light reflectance. And there are additional uncertainties connected also to the correctness of the model. In addition to this issue, it's also important to highlight the time of collection of the measurement. Satellites can either be stationary or orbiting. If ambient formaldehyde concentration is estimated using data collected from an orbiting satellite, then the concentration just is a snapshot of the estimated average concentration during the time of overpass of the satellite. In that sense, this data would be comparable to the 5 minutes empty data. Although again, I just want to clarify the additional source of uncertainty that is attached to this data source. Additionally, differently from the empty data that provides information on ambient formaldehyde concentration at a specific location, the estimate provided by a satellite would refer to the average value over a square grid cells. And it's also important to note that in the case of an orbiting satellite, data would be available only at the time of the overpass, which often would happen at somewhat regular intervals over the course of a week, with the frequency that depends on the orbit of the satellite. So this might result in only 2-3 estimates of average ambient formaldehyde concentration over a few minutes relative to approximately the same grid cells, also because the orbit is not always exactly the same. So this would not provide enough sample estimate to derive estimates of annual average concentration, which is what is needed to characterize long-term exposure. This problem would not exist in the case of a stationary satellite because a stationary satellite do not move. So for this type of satellite, the estimated ambient formaldehyde concentration would be available for a grid cell almost on a daily basis. And thus could be used to derive estimates of average annual ambient concentration of formaldehyde. Finally, a last point of note with respect to remote sensing data is the fact that remote sensing estimates are only available when measurement of right reflectance could take place. And those measurements are not available in the presence of clouds. So this would mean that the estimates of formaldehyde concentration that are derived from remote sensing instruments are not available in those location/grid cells that are covered by clouds during the time of the satellite overpass if the satellite is orbiting, or for those hours, time of the day during which the cloud obscure the view of the instrument aboard the satellite, if the satellite is stationary. Given the nature of formaldehyde and the reactivity of formaldehyde with sunlight, it could be argued that then the estimates of ambient formaldehyde concentration obtained from satellites might tend to underestimate the actual ambient formaldehyde concentration. In conclusion, while remote sensing might offer an additional source of information on formaldehyde concentration, it is important that ambient exposure of formaldehyde concentration derived from models, whether they are dispersion models, statistical models, algorithms that are underlying or hidden behind the remote sensing data, is validated, and the uncertainty in this type of data are represented and acknowledged. Yes, what else? Researchers have applied source apportionment with empty observation using the volatile organic carbon and other species measured simultaneously. This would offer an approach for identifying the sources that contribute to HCHO observation. So with that, I'll get back to Dr. Henneman for the last part.
Sure, just a few more comments from the committee. So these last few refer to the extent to which the weight of scientific evidence narrative is supported by outdoor air monitoring. And the committee thinks that this is important evidence that the model exposures are reasonable, but the conclusions are mostly qualitative because we don't observe source-specific formaldehyde. As for the weight of scientific evidence, while the individual terms or items, AirMod, AirTalk Screen, have been peer-reviewed and their use has been supported by previous committees for other tasks or goals, the fact that these models have been peer-reviewed and found sound does not necessarily mean that a not very careful application of these methods would lead to reasonable conclusions in the context of formaldehyde concentration source apportionment. Each individual comparison has merits, but there isn't inherent merit in each additional comparison. And then there are just a few minor editorial comments that I won't read in, but will be included in the in our write-up. So that's it. Thanks.
Right. Thank you both for that thorough response. Now I'd like to go to the associate discussants. This is George Cobb speaking, and the first discussant is Dr. McClellan.
Yes. This is Roger McClellan. Can you hear me?
Yes, sir.
I did not have the opportunity to participate extensively in terms of the group's discussion, but I want to emphasize that the US EPA's Air Office is well recognized as a group of individuals who are some of the world's authorities on these matters. And I agree that there could be much improvement in terms of how this work is put together, but I think that it is sufficient in terms of the present document. I will remind people that in terms of the air standards, they, in some case, they always include not only a value, but what we call the form of the standard. So dependent on the pollutant, there may be consideration of a daily average 24-hour, but there may also be a standard or value based on a 1 hour peak. So I had asked previously that the EPA have some individuals present from the Office of Air and Radiation to offer comments. I will make the overarching comment that I hope that when this document is revised, that this section will include participation from individuals from the Air Office to the extent that they are included as co-authors of the section. That will help give validity to the analyses and the conclusions drawn and any recommendations made as to a form of a standard. Thank you.
Thank you for that comment. Dr. Reif.
No further comments. These captured my opinions.
Thank you. So that is all of the discussants. Are there further comments from the committee?
Yes.
So this is what can you?
Are you there, Dr. Landis?
Yeah, my hand's up. I just.
Yes,
okay.
Please go ahead. Please proceed.
Yeah, I wanted to compliment the committee and Dr. Verical's excellent description of data, what they are, how they're used, providing all the uncertainties with derived information like remote sensing and other things like LOX and NOx. I wish I had copied some of that for my from teaching my graduate students. That was really well done. And it also points to the strengths and weaknesses of each one of these. So I just want to say great job.
Well, thank you. Thank you for that. Other comments from the committee? Okay, seeing none, that was quite an extensive response. So I want to see if there are clarifying questions from the EPA regarding this response?
Hi, this is Brian Groza from EPA. We do not have any further clarifying questions here. Thank you.
Okay, very good. Will you, this is George Cobb speaking again. Would you please read into the record charge question 6.2?
Okay, Brian Groza, EPA. This is charge question 6.2 on air monitoring data. Considering the variable time increments and locations of the samples included in the AMTIC dataset, please comment on the draft ambient air exposure assessment conclusion that AMTIC data represents long-term exposure concentrations. In your discussion, please discuss any adjustments to the monitoring data that could be completed to better align monitored concentrations with exposures and the timeframes associated with human health points of departure. For example, acute non-cancer or chronic non-cancer and cancer outcomes, considered in the draft human health hazard assessment.
All right, thank you. And we turn now to our discussants. And the lead is again Dr. Henneman.
Yes, you'll have the pain or pleasure of hearing from me a lot this morning. Here we go. As mentioned in the discussion of charge question 1, there was a lot of overlap between the two questions. The AMTIC data, while it represents a unique, invaluable information on ambient formaldehyde concentration, is marred by several limitations, most of which we've already elaborated on at length in the discussion to charge question 6.1. General note, descriptions of the AMTIC data are somewhat inconsistent, and there are some examples of the inconsistencies here that relate to the number of entries and the dates that are used for which the data has been extracted. And we sort of recommend standardizing those discussions. The next set of comments relates to the conclusion that AMTIC represents long-term exposure concentrations. While AMTIC monitoring data can be considered as providing information on the ambient formaldehyde concentration from all sources, inclusive of industrial releases, biogenic processes, and secondary formation, it is hard to think of the raw data as representative of long-term concentrations. The sampling duration, the differences in collection methods, each having its own detection limit and reliability characteristics, makes it hard to be able to say that each monitor provides a reliable estimate of the long-term exposure to ambient formaldehyde concentration experienced by the population living nearby the monitor. Panelist believes that in order to state that, the data needs to be statistically post-processed to obtain reliable daily average concentrations. The draft report for human health risk assessment discusses how nomenclatures such as daily average in quotes or annual averages in quotes are only allowed if more than 75% of the samples over an average time frame are available. Based on Table 2-4 of the draft report for human health risk assessment, the vast majority of the AMTIC samples do not sample long enough during a day to even be able to derive a daily average formaldehyde concentration. Only 1.64% of the AMTIC monitors have enough data available during the course of the day to be able to estimate a daily average ambient formaldehyde concentration at the site, and only 0.03% of the AMTIC sites, or 64 of them, have enough monitoring data available during the course of the year to be able to estimate the average annual ambient formaldehyde concentration from all sources. Given that the annual average ambient formaldehyde concentration can be estimated only at a very small percentage of AMTIC sites, a panelist believes that stating that the AMTIC data provide estimates of long-term average exposure to formaldehyde is not realistic, at least not under the current sampling scheme. Because of the fate and highly transient and reactive nature of formaldehyde and the way formaldehyde behaves in the presence of sunlight, other meteorological conditions, and other atmospheric chemicals, it is extremely important to know the timing of formaldehyde collections, both in terms of time of the day and time/day of the year during which the samples are collected. It would be useful to present which time of day the measurements were taken along with the sampling duration that is already presented. It's also important to have more description of the spatial distribution of the data as it relates to human exposure, including urban-rural representativeness and a summary of distances from TRI emission sites. Since Table 3-1 includes 233,961 valid samples and includes concentrations of 0, the 234,000 from 2.2.1 is apparently rounded approximation before excluding the values below the detection limit. And it's not understood why 15% of the samples were filtered out for being below the limit of detection per section 2.2.1. A recommendation that EPA should provide an explanation justification for this choice. After removing these non-detects or filtering the data, EPA is then left with usable concentration estimates from only 65% of the original entries, assuming all the invalid and filtered data represent low concentrations, and that is likely reasonable. The median of the full data set should be closer to the 23rd percentile. Similarly, EPA's 95th percentile becomes the 96.8th percentile of the original 306,529 entries, and there's more detail on the math in that we'll include in the report. EPA should do at least one sensitivity analysis where they retain the non-detect samples and/or invalid entries, but make assumptions about the values. For example, the concentration equals 1/2 the detection limit, as we've seen in previous or existing literature. It would be of interest to see which collection duration bins and geographic regions were represented among the excluded data to identify the risk characterizations most likely to have been affected by this choice. Comparing Table 3-1 and Figure 3-6 count information, it appears that the FluxSense data first became available in 2019. Since the FluxSense data are 5-minute samples, comparing the frequency diagrams for 2019 and 2020 to 2015 to 2020 could be like comparing apples and oranges. In that same vein, 2020 has a different frequency distribution shape than the preceding years. Were the FluxSense frequency distributions similar in those 2 years? When the data count increased from about 77,000 to about 121,000. So maybe FluxSense implementation occurred partway through 2019. And this sort of leads a lot of questions like, does that mean that 2019 and 2020 can be compared? Was there something going on related to the COVID-19 pandemic lockdowns? And an analysis like this could inform the relevance of 2020 data as a benchmark for future exposure estimates. There's a specific question about Figure 3-7. And then this last 3 comments here are related to any adjustments that could be completed to better align monitored concentrations with exposure and timeframes associated with human health points of departure. With regard to aligning monitoring data to PODs, the committee believes data could be better aligned with the underlying studies and realistic exposure scenarios for the acute POD. A member downloaded one AMTIC file from 2019 to get a sense of the available metadata and noted that the sample times are logged, among other things. And we have a lot of comments about reporting these sample times above. The data could be aligned to time of day and weighted to the assessment for the times of day that people are most frequently outside, for example, not 3 a.m. Also, the acute POD is most directly related to 3 to 5 hour exposures in the key studies. Moving average estimates of formaldehyde concentrations over a 4-hour period would better match the scenarios in the key acute studies. There's also note that formaldehyde varies in somewhat predictable diurnal and seasonal patterns, like higher in the summer and higher at midday, which influence observations application to taking an annual average. There are benefits in using the simpler, naive approach that the EPA use, but there are ways to build seasonal trends, and we have examples, for example, using moving average filters and some citations there. Lastly, for chronic endpoints, it might be possible to use consecutively reported samples to generate additional multi-hour TWA concentrations. However, the lesser relevance of, for example, overnight ambient air limits the duration of relevant moving average windows. And that's all I have.
Thank you for that thorough summary. There are several associate discussants, and we'll start with Dr. Barakal.
I don't have anything to add. My comments were captured by the summary of Dr. Henneman.
Thank you. Dr. McClellan.
Yes, this is Roger McClellan. I refer back to the comments I offered in terms of the previous section. I think some of these questions could well have been addressed with more active participation from individual scientists from the AIR office. And I think it's important in finalizing this section that there, again, is very active participation of individuals from the AIR office to the extent they are co-authors on the section. I will emphasize that air monitoring activities across the United States are very heavily influenced by the US EPA and particularly the standards it has for both criteria air pollutants and for hazardous air pollutants. So going forward, it's imperative that there be closer involvement of these several offices across the agency. I rest my comments there.
Thank you. Dr. Wright.
No additional comments.
Oh, thank you. Dr. Sweeney.
Likewise, no additional comments.
Oh, great. So this is George Cobb. I do have a comment relative to the no detect values, below detect values. And we've run into this in several panels of several committees. And the data are the data. There's nothing the EPA can do to change those data. But I will offer that we have seen limits of detection in previous data sets that I delved into where the limit of detection was the range of limits of detection were easily 2 orders of magnitude, if not 3. And when you've got detection limits that have that wide of variance, you can't assume that a no detect will put a concentration in the lower even quartile of the distribution. Sometimes we saw those things inching up towards the midpoint. I don't think they ever reached the midpoint, but towards the midpoint of the distribution of quantifiable values. So I take the point that initially, when you think about it, maybe all the no detects are at the low end of the distribution. And if you consider the lower quartile, the lower end, I agree, but it's certainly not even the lowest 5% where those limits of detection would lie if you applied if you were to know the actual concentration measured, because some of those older methods, the method detection limits simply weren't there because our instrumentation was not nearly as good during that time frame. So that's my comment. Oh, Dr. Barakal has her hand raised.
Yes, this is Dr. Barakal. I actually wanted to take the occasion to, you remind me of something that I noticed when I was reading the document, and there was a comment about how the concentration obtained from the bucket method tended to be larger. But actually looking at the table, it seemed that actually that method, were never zeros detection with that method, which makes me think of what you are mentioning, that the detection limit is different depending on the instrument that is used. And given that this monitoring data has so many different methods for measurements, this is really a great point.
And that points to the danger of using zeros for the non-detects, because if you've got a detection limit that's well into your distribution of measured values, and you assign that value a non-detect is zero, you don't know where in that distribution your value lies. So I think that's a great point. Thank you. Are there other comments from the committee? All right, seeing none, we'll go back to the EPA to see if there's clarifying questions.
What, George, one more point.
Oh, excuse me, Dr. Chasen, I see,
Yeah.
I saw a thumbs up. I thought that was an agreement. I didn't know that was a hand up.
Oh, I think I put the wrong little hand up. Sorry about that. I just wanted to tack on a comment that the conversation that you just had about the application of distributions of data, I think, is another example for the issue about how the data were used generically and the way distributions have or haven't been used and the assumptions that went along with them. And I suggest that, as we collect together those statistical issues, and Dr. Barakol perhaps could contribute to this, that we lay out some of those suggestions in a more coherent path. But this is another issue that is very much related to the use of multiple sources of data, which can be considered together with proper assumptions and understanding of how the distributions should be viewed, and what some of the practices are for looking at particularly lower tails and upper tails of these distributions. So I think this is once again worthy of inclusion in our effort to pull together a coherent statement about statistics used for the formaldehyde evaluation. If you agree, if this committee agrees, subcommittee agrees. Thank you.
Thank you, Dr. Chasen. So we'll go back to the EPA now for clarifying questions.
Hi, this is Brian Groza from EPA. Thank you for that. We don't have any further clarifying questions at this time.
All right. Well, Mr. Groza, if you will read in the next charge question, we'll give you a response.
Okay. I'm Brian Groza again with EPA, and this is charge question 6.3 in the human exposure model. EPA's human exposure model, HEM 4.2, and 6 years of toxic release inventory data were used to evaluate national scale population impacts of exposures to industrial releases of formaldehyde in the outdoor ambient air, based on site-specific information, including release location and census data. This is the first time EPA has used the HEM in a TSCA risk evaluation. Please comment on the application of the HEM for the purpose of identifying communities with elevated ambient air exposures to formaldehyde from industrial facilities and characterizing the exposed populations. In your response, please comment on the strengths and uncertainties associated with EPA's presentation of HEM results in section 2.4.2.3 and section 4.2.4.2 of the draft Human Health Risk Assessment, including figures 2.8 and 2.9 and tables 4.2 and 4.3 of that assessment.
All right, thank you for that. We can now move to our lead discussant, Dr. Fox.
Yes, thanks. This is Mary Fox. Our outline for response to 6.3, we have strengths, we have uncertainties and concerns, and we have some discussion about gaps related to important exposure scenarios missing from the assessment. So strengths in EPA's presentation here. So overall, the description and reasoning for using HEM and its basic features are clear. There are concerns with details of implementation, and we'll get to that. In table 4-3, this is an interesting analysis of disparities in risk by various demographic variables. And I glad to see that in the document. It's unclear how that disparities analysis was used, I think. But there are certain limitations in the 2020 census that should be acknowledged. And that moves us into our uncertainties. And we provide several references about the 2020 census related to the undercount of certain groups. And so limitation of the IIOAC and AirMod as used in HEM is that daily meteorological conditions, for example, the way the wind is blowing or inversions, that might vary concentrations by multiple orders of magnitude are not considered. It is also not clear whether other factors such as building downwash have been incorporated in the AirMod modeling. So a question, was AirMod run with daily meteorology or meteorology on some other temporal scale? More justification is needed for why the concentration contributions from TRI facilities are presented as a fraction of biogenic contribution from air tox screen. In figure 2-8 in the draft human health risk assessment, what do the dots represent? It appears as if concentrations are assigned to specific points, but this does not match the description of the figure. It would be helpful to identify and discuss the extent that multiple facilities contribute to elevated concentrations in any location. So TRI emissions are used. What is the variability across those 6 years? And is there any trend in those 6 years of data? It is understood that these are annual reported values, but the big worry for most of these sites would be whether there was a large accidental or planned release that accounts for most of the reported annual emissions. There may be information from these facilities' air permits that might add more information about the periodicity and magnitude of non-continuous emissions from these facilities. Table 4-2 in the draft human health risk assessment, values are presented rounded to the unit digit and without uncertainty. EPA should consider rounding to a level with more confidence based on the uncertainty in exposure data and population data. So census data is also uncertain. So we encourage the agency to, revisit this presentation and be consistent. Table 2-1 in the draft human health risk assessment. So NEI has stack parameters for some sources. How representative are the parameters used for IIOAC and AirMod and HEM. And it is unclear why the agency decided to use the TRI data rather than the NEI data. A comparison of releases reported in the two databases shows that the TRI tends to have lower release values, as oil and gas drilling industries tend to have the highest releases of formaldehyde. Yet that sector, in our understanding, is that it doesn't report to TRI or didn't during the 6-year window of data that were used. So by choosing to use release data from TRI, even if using the maximum release reported at a site, the ambient exposure estimated by the HEM would be an underestimate. Additionally, the number of TRI sites for which release data are available is dwarfed by the amount of release data available in the NEI. Hence, again, the results reported by the HEM analyses are likely underestimating the ambient exposure to formaldehyde. It is also unclear if the results the agency are presenting in figure 2.8 refers to a specific year or if it refers to an average across the 6 years of data. Neither the caption to the figure nor the text explaining figure 2.8 are derived in either the draft for human health risk assessment or the draft for the ambient air exposure assessment. It's just not very specific in that regard. On the contrary, the level of detail provided in the text is so high level, in certain instances, it's confusing, and it would make it impossible for anyone to replicate the results the agency has obtained and presented. Assuming the meteorological data for any given year have been used, the HEM model allows them to derive the estimated ambient formaldehyde daily concentration at each receptor point due to stack and fugitive releases. The latter are further averaged at each receptor site over the days in a year to obtain the average annual concentration due to stack, respectively, fugitive releases at each estimate or at each exposure point. The text is unclear then of what procedure is exactly used to aggregate the estimated annual exposure from the receptors to obtain the annual average concentration at the census block level. Did the agency overlay the boundaries of each census block in a map of the United States and select all the receptor points surrounding TRI sites that fall in the census block? Or what approach did the agency use? And where the annual average ambient concentration from the receptor points falling within a census block boundaries are averaged or summed together, this is not clear in the text. The text uses the word modeled total concentration, which seems to imply that the receptor average annual ambient concentrations were summed together, although this intuitively would lead to values much larger than the ones reported in figure 2.8. Providing clear explanations of how the census block ambient concentrations were derived is fundamental to be able to understand and interpret the results in the figure. Figure 2.8 finally displays the modeled annual formaldehyde concentration for each census block, with the census block shaded in different colors to indicate its range and its relationship to the 95th percentile of the biogenic threshold. It is unclear what is the benefit of showing whether a census block has an estimated ambient formaldehyde exposure annual concentration larger than the US-wide biogenic threshold. Both the ambient formaldehyde concentration and the concentration of formaldehyde related to biogenic sources vary spatially. Hence, it seems that it would make more sense to understand whether in a specific block, the amount of formaldehyde concentration due to TRI releases is greater than the 95th percentile of formaldehyde concentration due to biogenic sources at that location. This would be more protective to the population as it sets a threshold that is location specific, very likely lower than the national 95th percentile threshold. Figure 2.9 tries to compare the distribution of the ambient exposure concentration at the receptor points and evaluate the contribution of fugitive release versus stack release at different distances from a TRI site. However, it is unclear how the total, which is assumed to be the sum of fugitive and stack releases, has a median that is smaller than the median for one of the two terms that defines it. Secondly, these results do not consider the spatial distribution, as the concentrations for all the receptors are lumped together. So for example, there could be a receptor at 10 meters from a TRI site for which the concentration due to stack release is larger than the concentration due to fugitive release. And that might be true for all the receptors in a particular region of the United States because of the meteorological conditions and the dispersal. Yet one would not be able to identify this type of pattern, as here the results are collated over space. Finally, none of these results accounts for uncertainty in the estimated annual average ambient formaldehyde concentration. Given the large uncertainty surrounding this estimate, the committee encourages the agency to discuss the uncertainties and think about providing ranges of concentrations for each census block rather than presenting only one estimated annual average formaldehyde concentration. And now I'd like to turn to the concerns about missing exposure scenarios. And we have a slide that Dr. Chasen actually presented yesterday. And while we bring that up, I meant to mention this at the beginning, but in addition to our excellent discussion group, Dr. Chasen did contribute comments for this question 6.3. Great, thank you. So these comments build on the response that was provided for question 4.1, where the need for additional exposure scenarios was discussed. Consideration of only the industrial and consumer product scenarios miss an important array of other exposure scenarios. Several committee members from question 4.1 and others have challenged the EPA assertion that the calculations they presented are representative of the US population with no pest populations identified. Indeed, in question 4.1, high-density multi-use urban areas qualify as a pest for several reasons, including the probability that ambient air for residents near small businesses, auto body shops used as an example, and that's what's captured here in our photos, but also furniture repair and construction metal and duct fitting shops and other kinds of shops. The parameters discussed in EPA evaluations are too far to apply to these emissions where a human receptor lives only 10 meters away. EPA studied the air pollution provided from auto body shops, and we have a reference to that, noting 287,000 tons of volatile organic compounds are emitted each year, including volatile organic compounds. This reality provides daily opportunities for exposure to the surrounding populations in mixed-use urban areas. Exposure opportunities are greatest for the nearby residents, school children, and public in nearby spaces, indoor and outdoor. And again, our example photographs here. Again, this is a single source of formaldehyde composed of multiple conditions of use in a complex scenario. Any single COU contribution may be small if calculated at all, but in combination creates a significant exposure opportunity on a daily basis, presuming 6 days per week, repeatedly to the same people. EPA has calculated ambient air concentrations in the IIOAC model to represent exposure farther than 100 meters from a source of contamination. This is in the draft ambient air exposure assessment. Obviously, there are no football field sized spaces between the auto body shop rooftop vents in the homes and the preschool in these pictures. Ambient air concentrations of formaldehyde as calculated by EPA with these factors and assumptions are unlikely to represent daily exposures for these urban populations. Modeling for this mixed use urban setting could be estimated with the IIOAC model or preferably the HEM model. Literature is available on this issue with a variety of monitoring information studies and detailed information and other references will be provided. We also offer a few other comments, typos, and clarifications, but I won't read those out at this point. Thanks.
Thank you, Dr. Fox. So are there comments from the associate discussants? And that somehow left my screen. I've got to get back to it. I believe that was Dr. Barakal, you were first. Apologies.
No, my comments were captured by Dr. Fox summary.
Thank you. Dr. Henneman.
No additional comments. Thanks, Dr. Fox.
Dr. Landis.
I concur with this. What an excellent report.
Dr. McClellan.
Yes, I think the report was excellent, but it suffers again from the agency's failure to have included some of its experts from the Office of Air and Radiation in the preparation of this section of the report. Thank you.
Thank you for your comment. Dr. Wright.
No additional comments. I echo the others.
Thank you. So, this is George Cobb speaking again. Now we can turn back to the EPA to see if there are clarifying questions, and if they're not, we can move into the next charge question.
Hi, this is Brian Groza at EPA. Thank you for that. We don't have any additional clarifying questions. Okay, so this is charge 6.4, air tox screen. As described in the draft ambient air exposure assessment and the draft human health risk assessment, EPA recognizes that exposure to formaldehyde is the result of many sources. Please comment on the use of the 2019 air tox screen to describe different sources of formaldehyde and associated contributions to the overall exposure profile of formaldehyde in ambient air. In your response, discuss contributions of secondary formation and natural sources of formaldehyde in relation to contributions of formaldehyde from TSCA conditions of use.
All right, thank you. So we'll now turn to our discussants, and Dr. Henneman is up again.
All right, I'm back. Okay, so we have sort of two general sections that we covered here based on the charge question, and then one or 2 points overarching the rest. So as the agency described, they use the 2019 version of AirTalk Screen to be able to perform some form of source apportionment by estimating the ambient formaldehyde concentration at each census tract and break down the total ambient formaldehyde concentration into the contribution due to as many as 38 sources, which can be more broadly grouped as point sources, biogenic sources, and secondary formation, or EPA is specifically referencing these three throughout the document. To estimate ambient formaldehyde concentration at a given census tract, AirTalk Screen starts with information on the estimated amount of formaldehyde released by industries as reported in the 2017 NEI, and tracks its dispersion and reaction over space using CMAC and AirMod. Both of these models estimate dispersion of particles, also accounting for meteorology. CMAC accounts for chemistry. And these questions are on the first part, using air tox screen to describe different sources of formaldehyde. So EPA uses biogenic and secondary formaldehyde as baseline assessment, but the reasoning for this is not made clear. One can see some reasoning that formaldehyde is present in the air without TSCA use cases, but is unclear whether all the risk in ambient air is or should be discounted relative to biogenic or secondary sources. The committee notes a disconnect between the IIOAC results that reach up to 6 micrograms per meter cubed and air tox screen showing contributions from point sources of only up to 0.88 micrograms per meter cubed. And then the HEM model shows concentrations or contributions up to 8.9 micrograms per meter cubed. This is somewhat addressed by the discussion of HEM spatial scales at census blocks, air tox screen at census tracts, and IIOAC at specific distances from sources. But of course, there's more going on here, leading to an order of magnitude difference across the 3 models, including the air tox screen is based on a combination of chemical transport model and AirMod. In figure 3-4, there's a question and some recommendations for how to make that figure more legible. EPA uses air tox screen to estimate overall contributions from various sources, but spatial extent and contributions from various source categories would be useful to present too. Here again, it's recommended to harmonize the modeled concentrations and observations in space and time, as we discussed in 6.1, or the response to charge question 6.1. Figure 3.1 shows the resulting 2019 average annual formaldehyde ambient concentrations as estimated by air tox screen when all sources are considered and broken down by sources across all sites. While the plot is helpful to appreciate the range of annual average concentrations across the various census tracts in the United States, to be able to perform source apportionment, it is necessary to calculate at each census tract the ratios of the estimated formaldehyde concentration that can be attributed to a specific type of source in that census tract. For example, secondary formation to the estimated concentration due to all sources of the same census tract. The current figure does not show these ratios, thus not allowing to draw a conclusion. Taking the ratio of the mean average annual formaldehyde concentration due to point sources averaged across all census tracts and dividing it by the mean average annual formaldehyde concentration due to all sources, also averaged across all census tracts as currently reported in the draft ambient air exposure, is incorrect, as it completely ignores the fact that these 3 annual average concentrations due to point sources, biogenic sources, and secondary formation are not independent of each other. In general, when looking at the overall distribution of formaldehyde concentration due to secondary production, one can see those concentrations tend to be larger than the rest of the concentrations. The next set of comments are a discussion on the contributions of secondary formation and natural sources of formaldehyde in relation to contributions of formaldehyde from TSCA conditions of use. The committee notes that it seems arbitrary to compare the HEM model results with the 95th percentile biogenic contributions. Why biogenic and not secondary sources or even all sources? Biogenic contributions and secondary contributions vary in space, and the committee recommends comparing each facility's contribution from HEM or AirMod with the biogenic or total formaldehyde spatial. I think we had some comments about this in 3-1 or question 3.1. There's a question about how well do observations reflect total formaldehyde from air tox screen. By figure 3-8 in the ambient air exposure document, it appears air tox screen estimates lower concentrations and with a smaller spread, but it is difficult to compare because there are different numbers of observations, suggesting we are not comparing at the same location. There's some more discussion about trying to harmonize the comparison as closely as possible. One note for the IAOAC and AirMod is that they aren't considering photodegradation or reactions of formaldehyde in the air. To be able to perform some sort of source apportionment and estimate the contribution of formaldehyde from TSCA's COUs to the total formaldehyde concentration due to all sources, the agency plans to compare the estimated formaldehyde concentration as obtained using the IIOAC approach, which all considers the formaldehyde release from TSCA COUs to the estimated formaldehyde concentration obtained using air tox screen. Well, in theory, this seems to be an approximate way to perform some sort of source apportionment, as already commented in charge question 6.1. The problem is in the implementation. The concentrations estimated by IIOAC method and air tox screen are really not comparable for multiple reasons. First is the spatial misalignment. The two estimated concentrations do not refer to the same spatial locations. The IAOAC estimates of formaldehyde concentrations only refer to concentrations at selected locations from a certain distance. So, for example, averaged 100 meter to 1,000 meters from TRI facilities, while air tox screen concentrations refer to all census tract centroids. Two, different input sources. The IIOAC method uses an input the formaldehyde release from TRI facilities, while air tox screen uses NEI. There are sizable differences between the two databases in terms of the amount of data and even magnitude of releases, with the largest releases not included in the TRA dataset, and we have some comments about more thorough comparison between TRI and NEI. Three, static versus changing meteorology. The estimates of formaldehyde concentration obtained by IIOAC method are not derived using actual meteorological conditions, but using fixed meteorological conditions maintained constant for every day of the year. This can be deduced by the fact that the daily average ambient formaldehyde concentration is the same as the annual average ambient formaldehyde concentration. As we stated in question 6-1, given the high reactivity of formaldehyde and the way it behaves under differing meteorological conditions, not allowing the meteorological conditions to vary is not realistic and might yield estimates that are of formaldehyde concentration due to TSCA COUs that are too high or too low. So to be able to draw conclusions on the contribution of TSCA COUs to the total formaldehyde ambient concentrations due to all sources, the issues above should be addressed. Once they are addressed, the calculation of the ratio of the estimated formaldehyde concentration due to TSCA COUs at a given location and the estimated formaldehyde concentration due to all sources and estimated by air tox screen at the same location or at least in a neighborhood of the same location allows to quantify the percentage of formaldehyde concentration at a given location that's contributed to by TSCA COUs. Repeating such calculation for each location will allow us to see the variability in the contribution of TSCA COUs to the formaldehyde due to all sources across space. This variability is expected given the differing meteorological conditions over space and the variability in the density of and releases of industrial facilities of formaldehyde. And that's it.
All right. Thank you, Dr. Henneman. So now we can go to our associate discussants. And first up, we have Dr. Barakal.
Nothing to add. My comments were included in the summary that Dr. Henneman just went over.
Great, thank you. Dr. McClellan.
Yes, I just want to reemphasize the extent in which it is not apparent that the OPPP staff avail themselves of the best use of personnel in other offices, specifically the Office of Air and Radiation, in preparation of this document. It is disappointing that individuals from that office are apparently not present on at this virtual meeting, which is their input as members of the EPA staff would be greatly enhance the deliberations here. Thank you.
Thank you. Dr. Wright.
No additional comments from me.
Thank you. Dr. Voorhees. Dr. Voorhees mentioned he might have to step away for a while, but this is George Cobb speaking. He did email me indicating concurrence with the things that were written in the charge questions around charge question 6. Now we'll turn to the remainder of the committee. Are there other comments from committee members? Okay, so this is George Cobb speaking again. I do have one comment to offer here, and it could fit in a number of places. Those of you who are working on these charge questions so far, it's been Dr. Henneman and Dr. Fox. But there's been some consternation, much consternation about where the secondary exposures from formaldehyde are originating. And I understand that that's a complex issue. I will offer there's a publication from 2013 and several more recently, I believe, but I simply have ready access to the one in 2013. From here in Texas, there's large air quality campaigns down here in Texas that happen every year. And in one of those, authored by Zhang and others, including Oligar, who's a very well-known atmospheric chemist, that mentioned the source apportionment for secondary formaldehyde coming from industrial sources is 10 to 20%. And so actually it's 10 to 30%, excuse me. So I'll send this reference to you folks, but I think it's worthwhile to note that those estimates could very easily inform this risk assessment by being able to say, okay, the industrial contributions to formaldehyde have certain range. And if you've got different industries that are being assessed, you can distribute that that percentage across those in some way. So I simply wanted to offer that, and I'm sure there are other more recent versions of this that may shed some light on this process. So with that, if there are no further comments, I'd like to turn it back to the EPA to see if there are clarifying questions.
Hi, this is Brian Groza with EPA. Thank you for that. We have no further clarifying questions there.
Right. Thank you. So this is George Cobb speaking now. If Mr. Groza, you could read in the next charge question.
Okay, Brian Groza again with EPA, and this is charge 6.5, chronic non-cancer human health hazard data. The draft human health hazard assessment relies on the chronic inhalation hazard endpoints and PODs derived in the draft IRIS assessment on formaldehyde that have been peer-reviewed by NASEM. Section 4.2.4 of the draft Human Health Risk Assessment outlines the use of the chronic inhalation POD to assess risks to people with exposure to formaldehyde in outdoor air. Please comment on the strengths and uncertainties associated with OPPT's application of the chronic non-cancer inhalation POD for evaluation of formaldehyde risks through outdoor air.
All right, thank you very much. So now we can go to our discussants. And for this, we have Dr. Prisbilla.
Jennifer Prisbilla, lead discussant for 6.5. The robust discussion surrounding the chronic POD generated for charge questions 1.2, 3.3, and 4.4 captured all of the group's comments for question 6.5. Outdoor air exposure is experienced by essentially all ages, life stages, and occupation, with astronauts and submariners being among the few exceptions. But while people do almost universally experience outdoor air exposures, that experience tends to lower their time-weighted average personal exposure to formaldehyde. And then there's a reference to the draft Human Health Risk Assessment figure 412. Nonetheless, the concentration ranges are very large, so the upper end risk assessment would more or less assume someone is hanging out in a field next to the formaldehyde releasing facility all the time. Typically, relative to time spent at work or otherwise indoors, the time spent outdoors is small, and there's some comparisons between age ranges, and a reference is given for exposure, the Exposure Factors Handbook. Additionally, acute and chronic exposures from industrial releases of formaldehyde, which can be attributed to TSCA's COUs based on the IOAC modeling, are less than the formaldehyde concentrations in a typical home. Thank you.
Thanks for that summary. And now we can go to our associate discussants. Dr. Graham.
All of my comments were included. Thank you.
Great. Dr. Caden.
All of my comments were included. Thank you.
Dr. Kim.
I have no comments. Thank you.
Thank you. Dr. McClellan.
I have no comments.
Thank you. Dr. Sweeney.
My only comment is that this does the wide ranges of what one might experience for time outdoors versus time indoors sort of adds to what Dr. Chason has previously mentioned about a more distributional analysis, and that could definitely be not a uniform distribution, that you could have a limited number of outliers who are pretty high on that. My son likes to sleep in a hammock outside, so he could spend more than the average amount of time outdoors, but he's a minority in that regard.
All right, thank you. Dr. Wolf.
No additional comments.
All right, thank you for that. And this is George Cobb speaking. Dr. Prisbilla, you're so efficient. You're getting us way back on time here. I appreciate that. I'd like to turn back to the EPA to see if there are clarifying questions.
Hi, this is Brian Groza with EPA, and we have no further clarifying questions.
Okay. You know, I just realized I was so excited about getting back on time, I didn't go to the full committee to see if there were any comments. All right, let's get the final charge question for overarching question 6 and please read that into the record.
Okay, this is Brian Groza again, and I see that I'm not appearing on the camera. I'm not sure why. But this is question 6.6, Cancer Human Health Hazard Data. The draft Human Health Hazard Assessment relies on the cancer IUR derived in the draft IRIS assessment on formaldehyde that has been peer-reviewed by NASM. Section 4.2.4.1 of the draft Human Health Risk Assessment outlines the use of the cancer IUR to assess risks to people with exposure to formaldehyde in outdoor air. Please comment on the strengths and uncertainties associated with OPPT's application of the cancer IUR for evaluation of formaldehyde risks through outdoor air exposure.
All right, thank you. And we have Dr. Prisbilla again.
Jennifer Prisbilla, lead discussant for question 6.6. If you thought 6.5 was efficient, just wait for this one. So the robust discussion surrounding the cancer IUR generated for charge questions 3.4, 4.5, and 5.7 captured all the group's comments for question 6.6. Thank you.
Wow, now that was efficient. So that's good to hear. Let's go to the associate discussants to see if there are other comments. Dr. Graham.
All of my comments were included, thanks.
Great. I think we spent a lot of time hearing from some of you earlier in the week. Dr. Kaden.
All my comments were included. Thank you.
Dr. Kim.
Yes, I have one comment to make. So in my judgment, unless a clear differentiation is made between threshold and non-threshold carcinogen for formaldehyde, having or placing proper formaldehyde cancer risk assessment and management is not appropriate or practical. Therefore, it is my professional judgment and recommendation that clear differentiation between threshold and non-threshold carcinogen should be made for formaldehyde when agency is addressing the appropriateness of the use of cancer IUR for evaluation for formaldehyde risks through the outdoor air exposure. And I believe this comment is also relevant to charge question 4.5, 5.7, as well as 6.6. Thank you.
All right. Thank you for that. And Dr. Wolf.
No additional comments.
Great. So we're at
I'm sorry, this is Dr. McClellan. I wanted to I am included as a member, an associate discussing. I endorsed the comments that were made by the lead discussant, but I strongly endorse the comments that have just been offered by Dr. Kim. And I want to again re-echo the importance of the points that he is making as we go forward. Thank you.
That's very good. And I'm sorry I didn't have you on the list. Maybe mine was slightly before the very last revision, so I apologize for that. Thank you for your comment, though. Are there comments from the remainder of the committee? If not, are there clarifying comments or questions from EPA?
Hi, this is Brian Grozer from EPA again, and we have no clarifying questions. Thank you.
Okay, thank you. And Mr. Groza, your audio was fuzzy. I could understand you well enough for the record, I believe, but just as for future notice. We're coming up close to the top of the hour. I think I'd like to take a 10-minute break to the top of the hour, give everybody a minute, and then we'll come back at the top of the hour and hopefully finish out question 7 and be able to adjourn the meeting without taking a lunch break. That is my plan, unless I get some strong opposition.
That's a great plan.
So going to turn this back over to Ms. Gibson then to see if there are any
Okay.
remarks before our break.
I have no other remarks. We can come back at, is it 12 noon?
Thank you. See you all in
Yep.
just a minute.
Yep. Thank you.
Okay, welcome back. This is George Cobb speaking. I think we're ready now to move into charge question 7.1, unless Ms. Gibson has anything that we need to cover.
I do not. Thank you.
So, yes, please read in the charge question, and I think it's going to be Dr. Wegner.
Yeah, that's right. This is Susanna Wegner from the EPA. And I'll be reading in charge question 7.1. Section 4.3 of the draft Human Health Risk Assessment qualitatively considered the combined exposures that may result from multiple sources releasing formaldehyde to air in specific indoor or outdoor environments. For example, EPA's HEM analysis estimated exposures and risks from formaldehyde released to ambient air from all TRI facilities present in a particular location. EPA also used monitoring data to estimate aggregate exposures and risks from all sources of formaldehyde in a range of indoor and outdoor settings. Please comment on the strengths and uncertainties of EPA's approaches for estimating aggregate exposure and risk from multiple sources of formaldehyde through a specific pathway, i.e. indoor or outdoor air.
All right, thank you. I will say that when we come back, your audio was pretty low, and I don't have the problem of not being heard, but maybe if you can speak up a little bit, that would be helpful. But now we'll turn to Dr. Rubin.
Thank you. Rainbow Rubin. Regarding EPM's HEM analysis, estimated exposures and risk from formaldehyde released to ambient air from all TRI facilities present in a particular location, greater clarification was requested from the committee members on EPA's approach for aggregating releases from TRI facilities in a given area. Namely, was it over discrete time intervals, and was there a calculation of dissipation time or an assumption that these upper level /mean/median concentrations, unclear which values were used, represent a stable air concentration across long durations. A parallel example of multiple site emissions exists in most mixed-use urban areas relating to discussions in charge questions 4.1 and 4.3. Significant emissions 5 or 6 days per week of formaldehyde result from required ventilation of small auto body shops in urban areas. In geographical zones much smaller than a census block, there may be dozens of auto body shops and other small businesses using formaldehyde-based products. These properties are interspersed with residences, other public spaces like schools, playgrounds, preschool sites, clinics, retail, and restaurants. EPA studied this very scenario, calculated amounts of emissions under different circumstances, and issued advisories about it. It should be included here as these emissions are likely to expose at least as many, likely far more, people of all ages than exposed to the other site emissions. These mixed-use urban scenarios exist in most medium-large cities in the US. Additionally, the workers in these small auto body shops will experience exposure, inhalation, and dermal to dozens of formaldehyde-based car parts, upholstery components, lubricants, etc. on a daily basis. This group seems to be a consumer group as much as a non-employed person using car wax or leather products or other vehicle products. But these people have a full day's exposure profile, not a few minutes per day, and are exposed inside a building, not residents, but certainly indoors, with other workers, bystanders in the scheme of the EPA assessment, very nearby, even the office worker for the business, for example. Those assessments are missing, and the underlying exposure scenarios do not appear to exist. In the draft ambient air exposure for formaldehyde, EPA studied the air pollution provided from auto body shops, noting 287,000 tons of volatile organic compounds are emitted each year, including volatile organic compounds. See page 12 of the environmental exposure assessment for formaldehyde. This reality provides daily opportunities for exposure to the surrounding populations in mixed-use urban areas. Exposure opportunities are greatest for the nearby residents, school children, and public in nearby spaces, indoor and outdoor. Again, this is a single source of formaldehyde composed of multiple COUs in a complex scenario. Any single COU contribution may be small if calculated at all, but in combination creates a significant exposure opportunity on a daily basis, presumably 6 days per week, repeatedly to the same people. The strengths and uncertainties of the approach for estimating aggregate exposure and risk in the draft human health risk assessment were noted as follows. The reviewers found that it is not possible to answer this charge question solely based on the text described in section 4.3 and it's based on the text of section 4.3. Sections 2.3 and 2.4 of draft human health risk assessment, a US EPA 2024, describe the data sources and approaches used by EPA for indoor and outdoor air exposure assessment. Tables 2.1 and 2.2 document numerous data sources of indoor air monitoring in homes and mobile homes and some types of commercial buildings, school buildings, government buildings. These data will represent an aggregate of indoor sources. For outdoor air, EPA again describes multiple sources of data, both measured and modeled, reflecting a range of ambient conditions near facilities and attributed to various point and mobile sources. Strengths are that there are multiple sources of data in each setting. For indoor air in section 2.3.1, EPA identified over 800 monitoring studies, 290 of which are specific to the indoor air environment and associated with the 12 TSCA COUs subject to this risk evaluation. See Appendix A of the draft indoor air exposure assessment. For outdoor air in section 2.4, EPA discusses several EPA datasets and modeling sources that capture formaldehyde concentrations near facilities, as well as models representing general population exposures at the census tract level. From section 2.4.2.1, EPA's modeling evaluated industrial releases of formaldehyde that are associated with COUs from two separate databases, TRI and NEI. EPA compared releases and modeled concentrations from the two databases and found results were within the same estimated distribution range. The reviewers unanimously specified the need to quantify aggregate exposure. While we do not have sampling data for every possible exposure scenario, EPA is recommended to build on the considerable strengths of the data sets and models they have and develop a quantitative estimate of aggregate exposure for the indoor and outdoor air pathways. While it is a strength that section 4.3 of the draft human health risk assessment acknowledges how aggregate exposure is from multiple sources across multiple routes, across groups of people or pathways, there seems to be very limited information and action towards aggregate assessments. This section also stated very good examples of what these aggregate scenarios could be. For example, stating people could be exposed through indoor and outdoor air and occupational exposure. However, it did not seem to follow through with actual analyses and assessed these aggregate exposures. EPA concluded that there is too much uncertainty in the individual analyses underlying exposure and risks from individual pathways to support quantitative aggregate analysis. Although there might be uncertainty, there are steps that could be taken to conduct aggregate exposure assessments across pathways, such as simulations or other statistical modeling. Otherwise, there is potential for underestimation, and this would be detrimental for the general population, especially those in the susceptible subpopulation. The EPA considered that exposure can occur through multiple sources and provided scenarios in which people could have exposure through those multiple sources. Regarding uncertainties in this approach, given the EPA already used monitoring data to estimate risk associated with formaldehyde across individual routes of exposure, as noted on lines 2766 through 2768, EPA could, at the bare minimum, have added these risk estimates together to get a crude estimate of potential additive effects. The EPA's assumption that risks are not additive across routes was not justified based on the qualitative information provided. Although there are undoubtedly uncertainties associated with this approach to crudely estimate additive effects, the calculation could be conducted under a range of scenarios. Simulations may be one approach that could aid in these types of calculations and could reduce the uncertainty. In the draft risk evaluation, EPA considered sentinel exposures by considering populations who may have upper bound exposures, such as workers on lines 2792 through 2794. However, it's possible that people who are exposed to both indoor and outdoor air are also experiencing upper bound exposures. The qualitative approach seems to lack consideration for these individuals. The concept of estimating aggregate exposure and risk from multiple sources of formaldehyde through a specific pathway is an approach which facilitates consideration of multiple contributions to the pathway of exposure, hence consideration of either aggregated exposure estimates for many individual products through common exposure scenarios, or using monitored data specific to that pathway. Indeed, if both the monitoring data and the modeled estimations are considered, confidence of the range of pathway considerations is improved, as well as providing some indication of relative contribution across many products contributing to the aggregated concentration. However, EPA's consideration of simply indoor or outdoor and residence is too broad and omits very important pathways and vast numbers of exposed people. The concept can be focused to key microenvironments with both pulses of high exposure as well as long-term exposure, such as vehicle interiors, and conditions of outdoor emissions from general business in densely populated mixed-use urban areas relevant to PESS scenarios. In most deliberations about COUs or exposure scenarios or values for the parameters of the exposure assessment, indoor was not really considered. Rather, residence or a manufacturing facility were the focus. But other indoor areas should also be included as they become the venue for potential exposures and may involve a broad part of the U.S. population, such as retail spaces, warehouses, showrooms, hotel conference and guest rooms, schools, libraries, etc. Such exposure would result from a combination of products in those indoor spaces. Those products could off-gas formaldehyde, including flooring, furniture, decorative settings with glues and paints, multiple electronic items, vehicles, arts, furnishings, etc. For example, on page 11, lines 348 through 358, in the discussion regarding automotive care products, exposure assessments for each product in this category are considered in residential settings based on consumer use activities. While that is a legitimate approach, other considerations of use profile and an aggregation of exposures across many products used in businesses are absent. The existing exposure assessment for car wax considers a few minutes of a consumer who bought the product and polished their car. But what about businesses who purchase boxes of this product and use it frequently during the day, either themselves or nearby workstations, along with many other vehicle care and repair products, paints, greases, etc. These exposures are greater in terms of magnitude of exposure per unit time, dermal and inhalation, greater in duration of exposure, and far greater in terms of repetitive exposure, perhaps daily. In terms of bystander exposure, these businesses must exhaust the workspaces, which then provides daily airborne exposures to nearby residents and urban areas. The scenario is widespread in the cities of lower socioeconomics, where densely populated areas include both residential and business properties, schools and playgrounds, etc. These are challenged neighborhoods, easily viewed as PESS communities for their this exposure scenario. These exposures are the product of aggregation from multiple products, predictable combinations, which has been the subject of EPA research in the past. The same aggregation provides constant exposure to workers inside these businesses. Additional uncertainties of the EPA's approach regarding aggregate assessment are as follows. The proper identification and treatment of PESS is critically relevant to proper quantitative aggregate exposure assessment. EPA did not include females of reproductive age as a PESS, even though males of reproductive age are included. EPA stated that they will apply an uncertainty factor of 3 times for chronic inhalation, but has not proposed additional uncertainty factors specific to life stage, including early life or pregnancy, despite evidence demonstrating that these are vulnerable life stages. Formaldehyde exposure before pregnancy has been associated with increased time to conception, and women exposed to mixtures of chemicals that included formaldehyde in high amounts showed evidence of menstrual cycle disturbances, citations provided, which is indicative of the life stage susceptibility for women of reproductive age. Further, the initial identification of PESS should not be contingent on chemical-specific data availability. Rather, chemical-specific evidence, intrinsic and extrinsic susceptibility factors should be used to identify PESS and separately account for the elevated risks for each group. When such data are absent, the application of generic adjustment factors beyond the 10 times factor for human variability should be applied to ensure that risks to PESS are not underestimated. Citations provided. We also know that PESS are co-exposed to numerous chemicals, further justifying quantitative aggregate and cumulative assessment. A 2021 study used the TRI database to identify co-exposures to formaldehyde and 15 other chemicals with a shared adverse health outcome, respiratory carcinogens. The authors identified over 600 communities in the US with combined exposures to formaldehyde and at least one other respiratory carcinogen. Assessment of formaldehyde without considering other carcinogens for which co-exposures occur in the human population will underestimate risk because co-exposures to formaldehyde and multiple other carcinogens are prevalent in US communities and are known to increase the likelihood of developing cancer. Citations provided. Accounting for background sources is an additional important aspect of aggregate quantification. EPA did not account for multiple background sources of exposure in the formaldehyde draft risk evaluation, stating that all possible pathways of exposure to the general population, including secondary formation, uses as preservatives and baby products, could not be considered because they constitute non-TSCA uses. The National Academies of Science, Engineering, and Medicine recommend consideration of background exposures when conducting a risk evaluation for both individual chemicals and categories of chemicals through a cumulative risk assessment, citing the background exposures at even small doses may have a relevant biological effect. By not estimating total exposure from all potential pathways, EPA is significantly underestimating the risk of harm of formaldehyde in the general population. To comply with TSCA, EPA is recommended to evaluate formaldehyde and other carcinogens that are currently undergoing risk evaluation as a class of chemicals and conduct a cumulative risk assessment. It's the charge of TSCA and the policy of the US that the EPA should regulate chemical substances, not substances and mixtures, which present an unreasonable risk of injury to health or the environment, and to take action with respect to chemical substances and mixtures which are imminent hazards. TSCA grants EPA broad authority to review categories of chemicals when conducting risk evaluations, and that any action authorized or required to be taken by EPA under any provision of TSCA with respect to a chemical substance or mixture may be taken by EPA in accordance with that provision with respect to a category of chemical substance or mixtures. To illustrate this, the importance of cumulative assessment, I will briefly refer to 2 slides from a recently published UCLA study on the multi-ethnic cohort data with over 48,000 participants. Thank you for getting those slides up. Researchers calculated hazard ratios of breast cancer associated with exposure to air toxics, including formaldehyde, from the EPA national scale air toxics data over a 20-year period. Slide 1 shows the breast cancer cases attributable to exposure to the upper 3 quartiles of air toxics, measured or modeled at the census tract level. 14 of the 16 air toxics included in the study were significantly associated with breast cancer, with population attributable fractures ranging from 2 to 52%. As you can see, formaldehyde was one of these, but only one, illustrating the importance of cumulative assessment. Slide 2, please. Slide 2 shows the exposure concentration of air toxics on the left and population attributable fractions on the right, broken down by race and ethnicity, highlighting the disproportionate health impacts experienced by communities of colors. Note the yellow bars, which refer to African American study participants, who had higher population attributable fractures than other groups despite their similar exposure levels. These data illustrate the importance of quantitatively contextualizing aggregate and cumulative exposure using real-world scenarios. Thank you very much. Done with the slides. Regarding risk estimates for quantitative aggregation, the human health risk assessment should include acute non-cancer, chronic non-cancer, and cancer risk estimates for each condition of use. The figures in the human health risk assessment document do not provide detailed tables with quantitative risk values requisite for clear and transparent risk communication. EPA has presented these values in previous TSCA risk evaluations, and we request them to be a standard part of evaluation so that an explanation for EPA's conclusions are more robust. EPA states that its risk determinations for formaldehyde are made by placing the risk estimates in comparisons to benchmark values for each exposure scenario in a broader context of total formaldehyde exposure. An explanation or scientific rationale for what is meant by pragmatic and holistic evaluation and case-by-case and context-driven is missing. Also absent is why levels of naturally occurring formaldehyde are relevant to the determination of unreasonable risk from manufacture and processing of formaldehyde and use of formaldehyde in industrial, commercial, and consumer products. There is also missing rationale for comparisons made, including 1, maximum concentrations of formaldehyde in outdoor air used to determine unreasonable risk from workplace exposures, and 2, formaldehyde concentrations in homes used to determine unreasonable risk from workplace exposures. The fact that many formaldehyde exposed workers also experience high formaldehyde exposure in their homes or from outdoor air is not relevant to determination of the reasonableness of their workplace exposures, except in the context of assessing aggregate exposures from the various settings in combination. Also relevant to aggregate assessment is the use of central tendency versus high-end exposure estimates to inform risk characterization. Use of the high-end exposure estimates is consistent with the best available science, EPA's practice in previous TSCA risk assessments, and with the requirements of TSCA. However, in this RE, EPA states that it used central tendency exposure estimates for both chronic non-cancer and cancer risk determinations for occupational consumer exposure and indoor air. No statement for the rationale of this decision is provided other than the following. The basis for chronic non-cancer and cancer risk estimates for indoor air were designed to estimate concentrations at the central Sorry, I'm going to start that quote again. The basis for chronic non-cancer and cancer risk estimates for indoor air were designed to estimate concentrations at the central tendency because this represents the most common scenario in an indoor environment. In choosing to rely on the central tendency, EPA does not consider whether there is an unreasonable risk to individuals with greater exposures, disregarding the exposure levels of 50% of the population. Further, it fails to meet its obligation under TSCA to identify any unreasonable risk to BESS, defined as a group of individuals within the general population identified by the administrator who due to either greater susceptibility or greater exposure may be at greater risk than the general population of adverse health effects from exposure to a chemical substance or mixture, such as infants, children, pregnant women, workers, or the elderly. EPA has recommended to utilize epidemiological dose response data to generate quantitative estimates of non-cancer risk from formaldehyde exposures. In the draft risk evaluation of formaldehyde, EPA continues to rely on the outdated methods for non-cancer dose response analysis and risk characterization employed in previous TSCA risk evaluations. EPA's method for non-cancer risk evaluation do not provide a quantitative estimate of risk. Instead, they rely on calculation of a margin of exposure. The MOE does not estimate the proportion of the exposed population projected to experience a specified health endpoint or the number of individuals impacted, and it perpetuates an outdated scientific notion that a safe or no risk level of chemical exposure can be identified for a diverse exposed population, citations included. The National Academies and the World Health Organization have outlined more robust methods for risk estimation that more accurately account for variability and vulnerability across human population and have been demonstrated in published case studies, citations included. EPA has recommended to apply these methods to chronic non-cancer hazards identified in the draft IRIS assessment for which PODs were derived from animal data. In the case of formaldehyde, the draft IRIS assessment identified epidemiological studies with suitable data for POD estimations for multiple endpoints, including allergies, asthma, and reproductive toxicity. EPA is recommended to use the dose response data from these studies to estimate dose response functions that can be used to quantify risks of non-cancer effects at exposure levels relevant to the TSCA formaldehyde risk evaluation, as it has done previously for multiple pollutants and chemicals, including lead, mercury, arsenic, PFAS, and particulate matter. Finally, regarding the use of the phrase less certainty, EPA has applied a justification that it has less certainty of the contribution of the unreasonable risk to numerous exposure scenarios where formaldehyde exposures exceeded the level at which EPA determined humans experience adverse reductions in lung functions, which indicates a high certainty of unreasonable risk rather than less certainty. A rationale of this justification and an explanation of the departure from previous TSCA risk evaluations is missing. In conclusion, EPA is recommended to more accurately characterize real-world formaldehyde exposures and risks, including to potentially exposed or susceptible subpopulations. This includes revising the RE to reflect quantitative non-cancer risk assessments using high-end exposure and risk estimates, removing the use of any scientifically unsupported justifications that downplay or disregard risk, and adopting best available scientific methods like quantitative aggregate and cumulative risk assessment, both of which aim to better reflect real-world exposure scenarios. Thank you.
Thank you. Now we can go to our associate discussants. This is Dr. Cobb speaking. Dr. Chase.
I have nothing to add. Thank you, Dr. Rubin, for putting that together so well.
Dr. Ike.
Thanks, Dr. Rubin, for putting that together. I also have nothing to add. Thanks.
Thank you. Dr. Fox.
Nothing to add.
Thank you. Dr. Merced Nieves.
Echoing my colleagues, nothing to add, and thank you, Dr. Rubin, for putting that together.
Great. So now we have potential comments from the committee, and I see Dr. Graham's hand is up. Please proceed.
Hello, Cynthia Graham. I'm acknowledging that this group is discussing aggregate exposure, but I do believe we have to keep in mind that association does not equate to causality, especially in a population study where there are so many confounding exposures. And this was basically to comment on the graphs that you showed for breast cancer, but it would not only be in respect to breast cancer, but for any exposure. Thank you.
Thank you. And please make sure that Dr. Rubin gets that comment. Dr. Landis.
That was an impressive presentation and also a detailed analysis. I know everyone's tired. I do have some questions though. One, it seems to me that most of the industries and so forth are pretty common ones that were included. I have questions about, do you think that things like aviation, not just large airports, but there are numerous other kinds of aviation manufacturing going on? Some of it is actually not near an airport. It's just Boeing actually trucks airplane fuselages. They actually put them on trains to take them from the manufacturing site to where the final assembly is going to happen. Also shipping. I'm talking about shipping, not FedEx to our houses, but of course, and again, you can tell I live on the Puget Sound. There's a huge amount of shipping of oil, commodities, all kinds of things that are going on up and down through waterways and through the small towns, also into facilities like Vancouver, Seattle, Tacoma, what other West Coast ports, where there's a very large ships going in and out, along with the vehicles that are taking part in all that. Also, even in a small city like Bellingham, we have manufacturing. We actually build ships, maintain ships of various sizes in our harbor areas, which I would assume would also have some of the same kinds of exposures to formaldehyde that you get in a body shop or a car repair place or a car manufacturing site. So those are the kinds of sources I was wondering, do you think were adequately covered in the analyses? They're not as many, but they also, if you're in a coastal area, either on a marine system or in fresh water, these things might be important. Of course, some airports are huge manufacturing and other kinds of sites. So that's one question. The other thing is, I'm really happy to see the aggregate exposure and effects and people trying to deal with that. I think that's a very important aspect. And we talked earlier about the Silver Book. I call it the Silver Book, but it's Science and Decision Making from 2009. And that is covered, a lot of these questions are covered in that 2009 publication. And the reason I'm very familiar with it is I was on an EPA committee to see how that could be implemented or how that was going on within the agency after it was published. I think a lot of this, we can use that as an initial reference, as it was brought up this morning, where a lot of these recommendations were made. The last thing is, and I think this is a great point, that may apply to many of our reports. Often there's a statement that there's too much uncertainty, so a risk can't be made. And that seems to be a justification for not doing the calculation or to making a simpler calculation. I always wonder how they know, how someone knows there's too much uncertainty until you've actually made the calculation and to see, in fact, it doesn't contain any information or makes an unreasonable prediction. I don't understand how, okay, we have too much uncertainty, therefore there's no reason to make a calculation. To my mind, how can you make that statement unless you actually do the test? So I would like to emphasize that because it keeps coming up in statements. And I'm concerned that that can be seen as a out. Let's not deal with this particular kind of risk because we're going to say the uncertainty is too much. But there's not a calculation or an estimate of how much uncertainty would be too much to make that kind of calculation. That is a concern from these statements I'm seeing in the eco parts and in some of the other things I've looked at. So I know I've just given you a tons of questions and points, but these are things that I often see as going throughout it. I know specialized environments is because of my location, I see these all the time. Being a little town in the middle of it, between Vancouver and Seattle and shipping traffic and so forth, it's not clear that that would be captured for a location like Bellingham without incorporating some of those transportation activities. Thank you.
So this is George Cobb. Thank you, Dr. Landis. I guess first of all, we can put the first question at least back to the discussants. For Dr. Rubin, perhaps I will offer this, especially about the second point. I think we can turn that second point rather than a question into a recommendation, perhaps, that the EPA do the kinds of calculations and evaluate what the varying calculations within an uncertainty band would give you, using data from within several points in the uncertainty band would give you. So that would be what I would respond to your second question, Dr. Landis. Now, the first question I can't answer. Perhaps Dr. Rubin or one of the other discussants has an answer as to whether, if I understood it, rail transport generally or waterborne shipping was adequately captured in the assessment.
Right. So Dr. Cobb, that sounds like a reasonable course, but if we're going to make a recommendation from the committee, I guess what we should have is, for that second point, is to, I guess that would be something we all have to discuss, or the different committees would have to discuss and see whether or not that is something we want to go forward with as a committee.
I get your point, and we can discuss that here if folks have perspectives that differ from yours. Let's say.
All right.
And then as things get written, if people agree or disagree, they can speak up. But I'm not trying to squelch discussion. Simply, if all 22 of us have a say on that, we'll be here till tomorrow.
No, I agree. Thank you.
So back to the group for that first question. Do you have a response about the adequacy of capturing those modes of transportation? I think we heard that the transportation really wasn't included, but I'd like to hear from the discussant.
That's my understanding, but I would have to spend more time with it unless any of the other discussants have thoughts on it.
This is Chris Jason. Dr. Cobb, you already stated what I partially was going to say, was that the comments that Dr. Landis put out could be, I think, structured to additional or expanded recommendations, or additional ones, or expanding on the recommendations that Dr. Rubin has summarized. And secondly, Dr. Landis made a comment about its frustration, if you will, that there's a predetermination that something has uncertainty. And I think hand in hand with that are the sort of intuitive evaluations that are peppered throughout the different documents, stating things like, we've chosen the most, or the biggest, or the most important, or whatever exposure scenario prior to doing the calculations. It's like knowing what the biggest pile of something is before you look at it. And we've made that comment before, but I think that is another issue that's related to some of these things, that we should scan each of the documents and maybe highlight 4 EPA recommendations for other ways to approach the decision making. So, oh, I'm sorry. I thought the video doesn't always go on. I apologize. Maybe there's a delay or something. Anyway, I think we should. Oh, and the other thing I wanted to make was I did, of course, contribute from research that we've done before, this issue of, I've spent a lot of time in various states on exposure issues in mixed use, lower socioeconomic cities, as you can see. However, I recognize that the one example that I sent in is just one example. And people living in other parts of the country or having other professional experiences where you have these kinds of things, not necessarily in an urban setting, as Dr. Landis puts out, I think it would be helpful. I don't think there's any way that the EPA has been able to harvest all of this kind of representation, if you will, across the United States. So once again, the idea that what's in the exposure factor handbooks or anywhere else, it's a little bit difficult to make a claim that what we know about the environment and living conditions is in fact representative across the United States. So I would encourage Dr. Landis or anyone else that has analogous situations that bear on ambient, the idea that the calculations are, quote, representative across country, or that the building types are representative across the country or across socioeconomic groups, that be pointed out and added to the comments that we made at various charge questions. Thank you.
Thank you for that comment. Dr. Wolf.
Yeah, thank you. I just wanted to offer a suggestion to the Office of Pollution, Prevention, and Toxics with regard to general concerns about aggregating all sources of formaldehyde. I have the privilege to sit on a health advisory board that reviews drinking water contaminant risk assessments that are made available to be used by the Office of Water. OPPT might wish to consult with the Office of Water and consider relative source contribution as it is applied by the drinking water program and determine if OW's approach is appropriate for OPPT use. In OW's process, they set aside a percentage of the allowable exposure for sources other than through drinking water. OPPT could consider using a similar process and reduce the allowable exposure from the COUs by some percentage, thus potentially saving time trying to develop values for all sources and possibly better inform the unreasonable risk determination. Thank you.
Thank you, Dr. Wolf. This is George Cobb speaking, and I would offer that perhaps to Dr. McClellan's point that a similar kind of evaluation of what the Office of Air is doing may inform the inhalational exposure and other types of assessment there on the air side. So now we can go to Dr. Ottinger.
And this is just a quick comment to reinforce those by Dr. Chasen and Dr. Landis, which is that as I listen and I look at the maps and I hear the very encompassing discussions, it's clear that there are going to be dramatic differences between urban settings and more rural settings. Some of that dictated by the constraints for what can be considered in this review. But I think that there's merit in distinguishing some of these various kinds of scenarios, meaning specifically that in rural situations, there's an assumption that there's not going to be necessarily as much outdoor exposure, whereas in urban settings, there's going to be more concentrated sources that provide especially human risk, if you will. And I'm not quite sure how to approach this, but I think this is highly relevant across many of the charge questions. And that is a request for, as we bring our comments all together and coordinate them, that we consider some of these overarching trends that might be of use to the agency and in distilling a more clear understanding of what the risks and hazards may be overall. Thank you.
Thank you for that comment. Dr. Young. Sorry, John.
Yes, here's Lopin Zhang. I just have a quick question, maybe for EPA team. For aggregating exposure in this charged questions, I understand when the EPA gave the presentation earlier, they have a list of included exposure and another list of non-included exposures to formaldehyde. So for this, when we are talking about aggregating exposure, is that in this charged question, including the ones not on the list or not? For example, for occupational exposure, I keep saying, does that including the embalmers and other medical pathologists who use formalin for their job? Is that included in this or not? I just want to EPA to clarify when we talk about aggregating exposure to formaldehyde in this case, is only the source on their list, not including anything, from other source. Like the ones, you sign it to FIFRA, as the pesticides. So I just want to know, make it clear.
So, yes, thank you. Thank you for that comment. This is George Kopp speaking. And I see Dr. Wegner's come on. I'll get to you in just a second. It's my understanding that the EPA did not include things like embalming operations. I think we can make a recommendation if we think those should be included, and that the aggregation or not is there's a reference to what conditions of use are included, or refer back to the conditions of use for the document to be specific about what that aggregation is. So, but with that, I'll turn it over to Dr. Wegner for perhaps a response to that comment.
This is Susanna Wegner with EPA. That's essentially what I was going to say. When it comes to specific conditions of use that were outside of the scope of the assessment, they would not have been folded into aggregate directly, outside of any consideration of monitoring data that broadly captures a broad set of sources that are not necessarily individually identified within that data set.
So we could make the recommendation for include, the ones EPA didn't include it for now. Or what I think we can use, and I think if we don't include all the sources, we should say limited aggregating all, sources.
Yeah.
Now that we're not really aggregating all sources anyway.
So I think we can make that recommendation in our report. Yes, and I think we should. And this is George Kopp speaking. Thank you, Dr. Wegner, for that clarification. I hope I didn't step on your response. Dr. Chasen has a comment.
Yes, thank you. Dr. Wolf brought up some very important points, two of which I'd like to emphasize here. As we're speaking about increasing the number of considerations, if you will, and I really would like to caution the people from assuming that is going to yield a greater overall assessment of exposure. And I'm going to make the example also of for people that since 1990, the Office of Pesticide Programs has been using an ever improving form of aggregate assessment that has some merits in it that would apply absolutely directly to everything we've been talking about here. So it's not like the OPPT has to start from scratch. There are many existing tools that exist today that can be adapted for the kind of work that we're talking about. And one of them is the issue that Dr. Wolf brought up. In the existing kinds of exposure assessments that are done at OPP, one of the outputs traditionally since 1990 has been relative contribution to the overall exposure assessment. So for example, if you've got 50 different kinds of commodities that have a given pesticide on it. It's going to say, you know, something like potatoes contribute 30%, apples contribute 2%, whatever, so that it provides a regulatory perspective for the decision makers. And that is the kind of, I think, benefit of an aggregate assessment that could be very, very useful when you're looking at COUs. The equivalent of a COU in pesticides would be a given tolerance on a very specific food. Well, obviously, there's a second point of that, and that's why we keep bringing up this probabilistic approach. If in the morning you pick up an apple to eat, it's not likely that you're going to pick up an orange and a banana and a bunch of grapes and the other kinds of fruits. So there are probabilistic factors that are set for whether or not you're even going to have an exposure. And that is the kind of mathematics that needs to be applied here. You cannot just take all of these different sources of exposure and blindly add them up. And that, because that just creates a fake sense of exposure and risk. So as we implore the agency to do aggregate exposure assessment, I think we have to really strongly recommend that it's done in a way that is consistent with the building science of how you do an aggregate assessment that is both representative for all different kinds of communities and different kinds of people's life stages and vulnerabilities, but also is appropriate, if you will, in the way that it puts these things together. And I would like to present to either this charge question or whatever, some of the attributes of that type of aggregation that I think is would be very helpful for this very particularly for formaldehyde, where you have so many different possibilities for exposure. Thank you.
Yeah, I think certainly introduce that to the report. That would be excellent.
Thank you. I will do.
So now to the rest of the committee, additional comments? Okay, seeing none, I'll go back to Dr. Wegner to see if there are any comments or questions from the agency, from EPA.
This is Susanna Wegner with EPA. I do not have any clarifying questions. I'm not seeing any from my colleagues.
All right, thank you. Can you read in the final charge question?
Sure. So this is charge question 7.2. Section 4.3 of the draft Human Health Risk Assessment qualitatively considered aggregate exposures individuals may experience from multiple exposure sources. For example, individuals exposed to formaldehyde through work or through use of consumer products are expected to also have exposure to formaldehyde through outdoor air or through indoor air at home. EPA concluded that there is too much uncertainty in exposure and risk estimates for individual sources to support quantitative aggregation across more than one exposure scenario. Please comment on the extent to which this qualitative approach is supported by the available information. In your response, specifically describe the data that could potentially support an alternative approach and how that approach could be implemented.
Thank you. Now we can turn to our discussants, and Dr. Ike is the first discussant, the lead discussant, excuse me.
Thank you. And there is a lot of overlap in our response to this with 7.1, so I think I can be a little bit brief here. So for this charge question, the committee members generally disagreed with EPA's conclusion that there's too much uncertainty to support quantitative aggregation across the multiple exposure sources. The committee members generally thought that not attempting to do any sort of quantitative analysis was leading to misclassification of the risk. And that we also thought that the best available science does support aggregate quantitative exposure assessment. We noted that one way to possibly do this was that we thought there was a substantial amount in diversity of the available data to do a probabilistic approach to explore aggregate exposures across scenarios. For example, EPA could use the monitoring data with explanations as to the limitations and the range of plausible exposure values. And other data sources that could support probabilistic risk assessment include the monitoring data on ambient conditions near facilities and at the census tract level attributed to various sources. And we'll provide references that support some of those points. And if it's not possible to do a probabilistic risk assessment, another alternative approach could be to conduct a screening level sensitivity analysis, which could help develop exposure and risk estimates for workers and consumers COUs with medium or high confidence. We also suggest that if EPA reconsider the contributions of the monitoring data, and if EPA remains convinced that the monitoring data are more uncertain relative to the model data, then counter arguments should be made in the final report. Some reviewers also thought that indoor vehicle air should be included as a microenvironment relevant for all populations, and to additionally consider the challenges of indoor communities that were mentioned in the prior charge question. And we acknowledge that it may not be possible for the current risk assessment, just given the time considerations, but we recommend that EPA provide a competent, state-of-the-art, versatile exposure risk model, and will include publications that support that, as well as references for the components for the model in the written report. And we also suggest that EPA review the guidelines on general performance for aggregate exposure and risk assessment, and the EPA resources for exposure assessment tools for both aggregate and cumulative exposures. And again, that was also somewhat mentioned in charge question 7.1. And that is all I had for this.
Just for the record, I'm assuming that there's underlying examples and
Yes,
wording
yeah.
to flesh all of that out, just
Yes.
so that you don't run into problems getting things into the report. Yeah, okay, great. So let's go to, thank you for that summary. Let's go to Dr. Chasen for further comment.
No, I have no further comment. Thank you. I will point out, George, that there's a lot of overlap in some of these charge questions, so we may need some guidance as to not putting the same text over and over again as to how we should plant these comments coherently, once again, to collect them so they're not just dropped and peppered all over the place. So we'll need some help and guidance as to what the best way to do that would be.
We will do that after this particular meeting concludes. So thank you for that. Dr. Fox.
Nothing to add.
Thank you. Dr. Landis.
Nothing to add.
Thank you. Dr. Rubin.
Nothing to add. Thank you.
Dr. Jong.
Yeah, I like to thank Dr. Eck. Did a good job to include everybody's comments, but also I just want to add this. I know our group had a lot of discussions during the emails back and forth. So I just want to say I'm going to put my comments during the email into a document, and I'm going to send it to the group. Yeah, right now. So
this is George.
In case
speaking.
if not included, it's in the documents.
Okay. So this is George Cobb speaking. Are your comments that you will provide captured in the, or at least broad overviewed by what Dr. Ike presented here today?
Maybe not everything, because, I just asked the last question for recommendation about the aggregating exposure source, should including the one not. So I'm going to add that in. Okay. That's not discussed. So what I'm saying is I'm trying to make all my comments through the emails into one document. So
I see.
which are not lost during,
see.
sometimes you
Okay.
lost, yeah.
Okay, I understand. So thank you very much. Okay, those are the discussants. Now to the committee. Are there any final comments on question 7.2 from the committee? Okay, we're getting close to the end here. Dr. Wegner, are there clarifying questions from EPA?
This is Susanna Wegner. I don't think we have any clarifying questions. Thank you.
All right. This is George Cobb speaking. That brings us to the conclusion of our meeting. I would like to thank everyone who's participating today, the public, the committee, the EPA staff, our contractors. And with that, I'm going to turn this over, I think, to Ms. Gibson. I see Dr. Bohati is wanting perhaps to say something. So we can turn it over to Ms. Gibson.
Okay, actually, Dr. Bahati, did you have?
Yeah, can I chime in here real quick?
Yes.
I just
Please
wanted to briefly remind the panel, I know we've moved away from the topic, but I just want to remind the panel that OPPT has been engaged with many other offices within EPA through the development of the draft risk evaluation for formaldehyde. Specifically this morning, it was referenced a few times about our engagement with the Office of Air and Radiation. And I just want to make sure that everybody understands that we have been in consultation with our colleagues in OAR. In fact, we've regularly engaged them to inform them about the draft risk evaluation, and also engaged with them to understand the data that they provided, as well as the models that we were utilizing from them in the draft risk evaluation. So I just wanted to make sure that was clear. And then I just want to extend a thank you to everybody, to the panel and the public, for hanging on with us and our colleagues in PREB. So greatly appreciate everybody. Thank you very much, and enjoy the holiday weekend.
Yeah, and thank you for that comment. That's very helpful. Thanks to all the EPA staff, OPPT, that this has been a good interaction.
Dr. Cobb, this
Yes.
is Dr. McClellan. Will you recognize me?
Surely, please.
I'm a little bit concerned as to the operating procedures, and I know that we're going into another session after this is over, but I would hope that the record is not closed in terms of written comments and of an overarching nature. If not, I'd like to briefly make a comment at this point.
So if the comments have been captured or broadly covered in the discussions, they certainly can be entered, supporting information can be entered into the written record. So if you think they have not been captured.
I think that the comment of the last individual from EPA was really extremely broad. And I still have some serious questions with regard to that interaction with other offices of the agency. And I followed the agency from its origins and recall certainly involvement in terms of issues of formaldehyde going back a long ways. But I want to emphasize the long history of the agency dealing with the Clean Air Act and both criteria air pollutants and hazardous air pollutants, the extent to which it has developed approaches to regulation that take into account levels of exposure, duration, and then these are reflected in the variety of standards, and always including then the form of the standard, including a statistical form. I don't think the documents, the multitude of documents, 50 plus, adequately reflect that. It was later that TSCA was passed, and that assignment responsibility was assigned to EPA, and that's gone forward through the years. And now the passage of the Lautenberger amendments, which provide additional focus. What has not been clear to me, as I've already noted, is specific interactions with the other offices. And we've heard, I've mentioned the Office of Air and Radiation. Dr. Wolf mentioned the water. I go beyond that, where it has not been clear to me how the agency has solicited comments from other agencies that have substantial interest in the matters that have been discussed here. And I refer to the Department of Agriculture, Food and Drug Administration, Occupational Safety and Health Administration. We have not, to the best of my knowledge, seen any written comments from those agencies.
So, Dr. McClellan, Dr. McClellan, this is George Cobb. You've made these perspectives abundantly clear, and that any of this can be entered into the written documents. I don't think we need to go through this chapter and verse again.
Thank you for that comment in terms of addressing that. There's one other issue which I think is very important, and it has not been clear in terms of the clarity of EPA's potential range of regulatory actions. And while we have focused on the science, tried to see that the best available science has been applied, it has not been clear as to the contextual use of that science in informing policy judgments that I believe are the exclusive domain of the EPA administrator. Thank you.
Thank you so much. Dr. McClellan, thank you.
So, Ms. Gibson, this is George Cobb. I understand from the chat that there's perhaps Dr. Morris from the EPA was trying to make a comment, or perhaps not.
No, I apologize. This is Dr. Morris. My mic was inadvertently unmuted.
I see.
Okay.
Great. Okay.
Okay.
Great.
That's good. So, Ms. Gibson, please.
Okay. All right. Thank you, Dr. Cobb. Greatly appreciate it. And before we close, I would like to thank everyone who contributed to this meeting. Dr. Cobb, I would like to thank you for leading such an important meeting and going through all of the agenda items and following the FACA requirements. Thank you to the SAC committee members and ad hoc reviewers for their input and participation in the meeting. And many thanks to our contractor Indina for their assistance in the Zoom meeting for preparation and also for the YouTube webcasting. Thanks are also due to the extraordinary team in OPPT for presenting the draft documents and responding to the committee's questions. Thanks also for the public for presenting their oral comments at the beginning of the meeting on day 2. And we also ask that the committee members to stay on for a brief meeting. Everyone else can depart from the meeting. The Science Advisory Committee on Chemicals meeting on the review of the 2024 draft risk evaluation on formaldehyde is now adjourned. And thank you all.
Thank you, Ms. Gibson.
Thank you.
quick, Camille. So ad hoc reviews should stay on or off? Are we?
Yes,
Okay.
everyone should stay on. Then 1 second until we cease streaming of YouTube.
Thanks.
All SAC members and ad hoc members.
Yeah, did I not say?
We're just waiting. This is Charlie Matton. We're just waiting for the EPA presenters from OPPT to leave this meeting.
Okay.